Good day, grade 8 learners. In this video, you are going to learn about operations on rational algebraic expressions. You will specifically learn about Module 5, Lesson 1, Multiplying Rational Algebraic Expressions. What I need to know. At the end of the lesson, you are expected to demonstrate understanding of the key concepts of multiplying rational algebraic expressions, and multiply rational algebraic expressions. What's in? Let's recall your knowledge about fraction. Do you still remember what is a fraction? A fraction is a numerical representation which indicates that one number is part of a whole. And there are four operations that you have to remember in evaluating a fraction. First is multiplication. We also have division. Addition, and subtraction. Now let's have a review on multiplying fractions. Now let's have this number 1. 4 over 5 times 3 over 4. In multiplying a fraction, all we have to do is just to multiply the numerator to another numerator and then the denominator to another denominator of the fraction. So in this case, we have 4 times 3 is equal to 12 and 5 times 4 is equal to 20. And as you can see, we can still reduce it to lowest term. 12 over 20 can still be reducible to lowest term. So all we have to do is just to divide the numerator and then the denominator with its greatest common factor, which is 4. So let's divide the numerator and then the denominator with 4. So we will get, so 12 divided by 4 is equal to 3. And then 20 divided by 4 is equal to 5. So we got here 12 over 20 is also equal to 3 over 5. And take note, always express your answer to its simplest form. Now let's have this next number, 1 over 7 times 6 over 5. Yes, once again, all you have to do is just to multiply numerator to numerator, then denominator to denominator. So we will get 1 times 6 is equal to 6, and 7 times 5 is equal to 35. And since we cannot reduce it to lowest term, so our answer is just 6 over 35. Now let's have number 3. 8 over 9 times 1 over 4. Multiply. 8 times 1 is equal to 8, and 9 times 4 is equal to 36. 8 over 36 can still be expressed to simplest form by dividing to its greatest common factor, which is 4. So let's divide. 8 divided by 4 is equal to 2. And 36 divided by 4 is equal to 9. So 8 over 36 can also be written as 2 over 9. You were already able to recall your knowledge in multiplying a fraction. But how about if you are already given a fraction with variables? How are you going to answer it? What's new? Let's take this example. 6 times the quantity of r plus 2 over 20 times 4r over 6 times the quantity of r plus 2. The answer is r over 5. But how did we get this answer? So let's find out through the next page. What is it? So how to multiply rational algebraic expressions? Let's remember this. The product of two rational expressions is the product of the numerators divided by the product of the denominators. In symbols, we have a over b times c over d equals AC over BD, wherein BD should not be equal to 0. Let's have this example. Find the product of 2x over 5 times 9 over 6x squared. So, following the rule, all we have to do is just to multiply 2x times 9. So, we will get 18x. And we will also multiply the denominator 5 times 6x squared. So, we will have 30x squared. As you can see, 18x over 30x squared can still be reduced to lowest term. So all we have to do is to get the GCF, or the greatest common factor, of the numerator and denominator. For the numerical coefficients 18 and 30, the GCF is 6. And for the literal coefficient x and x squared, we have the GCF x. But how did we get x? In this case, we simply chose the variable with least exponent. So the GCF for both numerator and denominator is 6x, and then divide. Now let's divide 18x by 6x. So the answer is 3. And now let's have 30x squared divided by 6x. So the answer is 5x. Just take note that when we divide a fraction with variable and exponents, we have to remember the law of exponent, which is the quotient rule. So this rule states that when the exponents with the same base are being divided, we just have to simply subtract the exponents to simplify the expression. So in this case, let's have this, for example, the numerator 18x divided by 6x. So x here has an imaginary 1 exponent, and the 6x also has the 1 imaginary exponent. So we just have to since they have the same base, we just have to subtract their exponent. So x to the power of 1 minus x to the power of 1 is equal to x to the power of 0. And take note, x to the power of 0 is equal to 1. So multiply 3 times 1 is equal to 3. That's why we got 3 here as the answer. So for the denominator, applying the same rule, we have here x squared minus x to the power of 1. So we will get x to the power of 1, or simply just write x. But if you subtract the exponents and the number is negative, just put the whole term in the denominator and make the exponent positive. I hope you were able to get it. Now let's proceed to the next number. So we have here number 2. Let's multiply 6x squared over 4y squared and 8x squared times y cubed over 30x cubed. Now, let's multiply first the numerator of each expression. So we will multiply 6x squared to 8x squared y cubed. And applying the product rule of the law of exponent, we will add the exponents with the same base. Yes, and we have here x squared, which has the same base. So we will just multiply that one. So we will multiply first our numerical coefficient, so which is 6 and 8. So multiply 6 times 8, it's equal to 48. And we have also here, we will also multiply x squared to x squared. And as what I have said, applying the law of exponent, the product rule, just add the exponent. So we will have x to the power of 4. And then just copy y cubed. So we have here 48x to the power of 4 y cubed. Now, let's proceed to the denominator. So let's multiply the denominator of the two expressions. So we have 4y cubed times 4y squared times 30x cubed. So since there is no variable, or there is no the same variable, so we just have to copy these variables here and multiply. So we have here 4 times 30 is equal to 120 y squared x cubed. So our answer is 48 x to the power of 4 y cubed over 120 y squared x cubed. We can still simplify 48x to the power of 4y cubed over 120 y squared x cubed to lowest term. So just get the GCF of the value of both the numerator and denominator, and that is 24. That's for the numerical coefficient. And for the literal coefficients, so we will just choose the variables with least exponents. So that's why we got here x cubed and y squared. And just take note that if, for example, the exponents of the exponents of the literal coefficients are just the same, then all you have to do is just copy the variable. Now we can divide this expression and simplify. Now, let's divide our expression 48x to the power of 4y cubed over 120y squared x cubed to its greatest common factor, which is 24x cubed y squared. So let's have 48x to the power of 4y cubed divided by 24x cubed y squared, and we will get 2xy. So remember our law of exponent, the quotient rule. So we just have to subtract the exponent with the same base. So that's why we got 2xy. Now let's divide 120y squared x cubed to 24x cubed y squared. So we got 5. So we just canceled out x cubed y squared. So since as we applied the law of quotient, the law of exponent, the quotient rule, so x cubed minus x cubed is equal to x to the power of 0. And it is equal to 1, and y squared to the minus y squared is equal to y to the power of 0, and that is also equal to 1. So 5 times 1 times 1 is equal to 5. So our simplified expression is 2xy over 5. I believe you are now learning how to multiply rational algebraic expressions. So now let's proceed to our third and final example. So we have here 5x minus 20 over 2y minus 6 times y squared minus 9 over x squared minus x minus 12. So, in solving these rational algebraic expressions, we have to recall our knowledge in factoring. So, let's start by factoring this first expression, 5x minus 20 over 2y minus 6. To factor this out, we need to recall about getting the greatest common monomial factor. So for 5x minus 20, as we factor this out, the greatest common monomial factor is 5, and the remaining factor is x minus 4. Now, for its denominator, 2y minus 6, the greatest common monomial factor is 2, and the remaining factor is y minus 3. For the second rational expression, y squared minus 9 over x squared minus x minus 12, y squared minus 9 can be factored out using the difference of squares, in which we will be following the formula a squared minus b squared is equal to the quantity of a plus b times the quantity of a minus b. We need to extract y squared and 9 by getting its square root. Then copy the formula. So we got here the quantity of y minus 3 times the quantity of y plus 3 as its factor. For the denominator of this second expression, x squared minus x minus 12, as you can see, it is a quadratic trinomial in the form of ax squared plus bx plus c. So the first step that we are going to do is to factor the first term, which is x squared. So it will become x times x. Then, we have to list all the pairs of numbers with a product equal to negative 12. So we have here the list of numbers in which we can get the product of negative 12, negative 4 times 3, negative 12 times 1, negative 6 times 2. But take note, we need to choose the pair which will result to negative 1 or the middle term. So from this list of pairs, we need to get a negative 1 as the middle term. So as we add the numbers, so let's add negative 4 times 3, negative 4 plus 3, so we will get negative 1. But for negative 12 plus 1, we will only get negative 11. For negative 6 plus 2, we can only get negative 4. So from this list, we only have negative 4 and negative 3 as the pair of numbers. Again, we need to choose a pair of number which will result to have the product of the last term. In this case, we have negative 12. And also, as we will add the two numbers, we will get the result of the middle term. So that's why in this expression, we got negative 4 and 3. So our factor for x squared minus x minus 12 is equal to the quantity of x minus 4 times the quantity of x plus 3. And we can check if this is the correct factor using the FOIL method. FOIL method means first, outer, inner, and last. So multiply the first factor, all the first factor, and then the outer, the inner, and the last. So that is how you're going to check if the factors are correct. Next, we already got the factors of each expressions. So we just have to cancel out the common factors for both numerator and denominator. So we have here x minus 4 as the common, and we also have another one which is y minus 3. So as we simplify this, we will be able to get this answer 5 times the quantity of y plus 3 over 2 times the quantity of x plus 3, in which, as we simplify, we will get 5y plus 15 over 2x plus 6. Thus, the product of 5x minus 20 over 2y minus 6 and y squared minus 9 over x squared minus x minus 12 is equal to 5y plus 15 over 2x plus 6. Yes, you already know how to multiply rational algebraic expressions. And this time, let's check your knowledge. So we have here what's more. Directions. Answer the activity below to measure your understanding about the lesson. Use a separate sheet of paper for your answers. Activity 1.1. Find the product of the following rational algebraic expressions. We have here number 1, 8m over 5 times 10 over 2m. We have number 2, 5r plus 50 over r plus 10 times r minus 2 over 5. Number 3, a squared minus b squared over 2ab times a squared over a minus b. Number 4, x squared minus 3x over x squared plus 3x minus 10 times x squared minus 4 over x squared minus x minus 6. And the last number, m plus 1 over 3m minus 15 times 8m minus 80 over m squared minus 9m minus 10. I know you will be able to answer this. Good luck! And here's the key points for this lesson and what you need to remember. The product of two rational expressions is the product of the numerators divided by the product of the denominators. In symbols, we have a over b times c over d is equal to ac over bd, in which bd is not equal to 0. As we end this lesson, allow me to give you this quotation from John Wicker: opportunities multiply as they are seized. They die when neglected. So just keep seizing your opportunities. And that's all for this lesson. I hope you learned something.